So today we're going to looking at something called logarithmic equations. And so far we have learned linear equations. When you have something like, say, 2x plus 3 equal to 5, or quadratic equations. Quadratic equations have the quadratic term, which is x squared. So it could have, say, 2x squared plus 3x plus 1 equal to 0. That's a quadratic equation. And then we also have, that's jet, rational equations. Rational equations, something like, say, 1 over x plus 1 plus 1 over minus 1 equals to 0, things like that. And also radical equations, which have the radical sign, something like this. And so the trick for solving rational equation and radical equation jet equations is actually change them to either linear equation or quadratic equation. So similarly, when we do this logarithmic equations, we're going to change that to either linear equation or quadratic equation. Okay. But before we do quadratic equations, we also can see the something called exponential equations. Equations. And so when we say 2x equals to 8, now we call this exponential equation because the x is on the exponent, is an exponent. In this case, we can, the sort of solution for that is this is equal to 2 to the third. So therefore, x equals to 3. Yeah, are we good on here? Okay. Yeah. Jed, are we good? Okay. Now, sometimes it's going to be a little bit more complicated than that. So it'd be 3, 2x plus 1 equals to, let's say, 27. Now, we know the 27 can write as 3 to the third, same base. So therefore, 2x plus 1 has to equal to 3. Now, this is a linear equation. We know 2x is 2, then x equals 1. Good? Yeah. Okay. Jed, we good? Okay. So now we're going to looking at something which basically is a different way of writing the uh, exponential equations. We call logarithmic because remember this term is also just called logarithm. So if I have something like this, um, we got okay. Now we know this one. This means if we write x as oh, as a exponent of as base of 3, what is the exponent? We know the exponent is 2. So therefore, x is 3 to the second power, which give us 9, which is kind of in the reverse way as we did exponent. Yeah. Are we good on this one? Okay. All right. So now we can look at some examples. For example, log 5 x is equal to log 5 to the 7. So in this case now, same base. So therefore, x has to equal 7. And now sometimes maybe a little bit more complicated. Let's say log 7 x plus 3 equals to log 7 and go to 5. So in this case now, same base, then x plus 3 has equal to 5, then x is minus 3 on both sides equals 2. And we can check by plugging x equal to 2 back to here, which is 2 plus 3 is 5. Yeah. Okay, we good on this one? All right, so I'll give you a couple to just work on. Okay, see what you got. Okay.
Quick question. So how am I supposed to write this out?
Well,
I
there's basically, in order for the both sides to be to equal, then
okay.
x plus 1 has to equal to 10. Good? Because they have the same base.
Oh, okay. So yeah, sorry.
Yeah, and then we just solve that as a linear equation.
So okay. How would I do that?
Well, remember how to solve linear equation?
Yes,
Okay, that's what we're doing. Solve linear equation.
2x plus 1 is equal to 10.
All right.
Okay.
Good job, Jet. Good job.
Eh, do 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 do.
Did I get the answer right?
Yeah.
Oh, okay. Good.
All right. So let's see that. Okay. Log 2x plus 1. In order for this one to be true, and also because we have the same base, then 2x plus 1 has equal to 10, right? So to make this both sides, basically we just have to make this as 10. Log 10 is equal to log 10. So that's what the equation means, is like what x value should be to make sure this equation is true. So therefore, 2x plus 1 is 10. To solve that, minus 1 on both sides. And we got 2x equal to 9. Then we divide by 2 on both sides. So therefore, x is 9 over 2. Good. Yeah. So what we did here is to change this logarithm equation into a linear equation, and then we're solving it. Okay, so let's try log 3, then x 3x minus 1 equal to log 3. That's the key. You have to have the same base. 27. Okay.
A quick question, is that third to the 27th power? I'm a bit confused, or is it
Oh,
just
no, that's just log,
3x minus 1 is equal to 27?
that's a log 27. So this 3 means the base for the log.
Oh, okay, so
Just kind of saying, what kind of log are we talking about?
yeah, I'm still confused, I think. Unless it just literally means 3x minus 1 is equal to 27, right?
Yep. Same
Okay.
base, same base. So what? So basically saying if you have the same base, what is 3x minus 1 should be equal to
Right.
to keep that the equation.
Okay. Huh. There.
Good job, Asher. Yeah, good job, Jet.
Yes.
Okay, I'm confused.
Well, in order for these two sides are the same, what 3x minus 1 has to be? It has to be 27, right? Good.
Oh, I didn't see the 3 down there. That makes sense.
Yeah, so therefore, to find what x is, that's linear equation. We add 1 on both sides, then 3x equal 28, then we divide by 3, then x is 28 over 3.
That makes sense. I wasn't zoomed in the whole time, so I didn't see that. Sorry.
It has to be the same base, otherwise this won't equal. For example, the simple thing you can see here, log 3 to the 5th is not the same as log base 2 to the 5th and 5. They won't be equal. Has to have the same base to have the equality there. Okay, are we good on this?
Mm-hmm. Thank you.
Yeah, Morgan? Okay. Now we can do something a little bit more interesting, is that remember what we learned early on is we learned this. There's 2 rules actually, or 3 rules of logarithm. When you have this, that is log x plus log y, and log x over y, that is log x minus log y. Yeah. And right now I'm using base 10, and that works for any base as long as we are consistent, the same base we're using. And we also have this log x to the nth power, that is n times log x. Okay, are we good on this one? This is what we learned last week. Good. Okay. Asher and Jet, are you guys good?
Yes, sir.
Okay, now we actually can also go the other way, because this is the equation. So this plus that is going to equal to log xy. We basically just playing kind of showing that the property we have. Then log x minus log y, that'd be log x over y. Okay. Yeah, are we good on that? All right. And also n log x, that basically just log xn. So we just basically going the other way. Okay, knowing that, this is help us to solve some log functions. So I got log 5 here as the base. Then this is x plus 7 and plus log 5 and 2 and equals log 3, sorry, 5 and 20. So to solve this, first of all, we have to combine them. This one we know this side is log base 5, then 2x plus 7. And the other side will be log 5 and 20. So now same base, so therefore 2x plus 7 should equal to 20. Then we divide by 2 on both sides. We got x plus 7 equals 10. Then minus, sorry, minus 7. Then x is 3. And we can also plug in. If we plug in, we can see that x 3 plus 7 is 10. 10 times 2 is 20. So that's a solution. Okay, are we good on this one? Okay, yeah, Jet. All right, so let's just try one. We got log x plus 8, then plus log 4 equals log 80. And see what you got. Good job. Good job, Jet.
Oh shoot, I didn't realize. Sorry.
Okay, so let's see how we do this one. Okay, it looks like some of you still struggling with this. When we put this together, what we have, that is log x plus 8 times 4. Good. That's what we have. On the right side is this. Now, are we good on here? So if that's the case, then 4 times x plus 8 equals to 80. Then x plus 8 will be 20, right? We divide by 4 on both sides. Yeah, or times 1/4. So therefore, 8 will be equal to 12. Yeah.
Oh shoot, I forgot. Yeah.
Are we good here?
Yeah, that makes a lot of sense. Thank you.
Okay, yes.
Yep.
I think I have it now.
Forgot that stuff.
Archer, how did you get 68?
Um, so I did it wrong. Um,
Which step?
so I added 8 and 4. Yeah, no, that doesn't make any sense. Sorry.
No, that's all right. No, that's fine. This is,
I wasn't thinking.
yeah,
All right.
yeah. That's how we learn to figure out how did we get wrong
Mhm.
to make corrections. Okay, let's try one more on this one. Log x minus 1 plus log 3 equals to log 12, and see what you got. Good job, Jet.
Sorry.
Oh, sure, you,
What's up?
okay.
Well, I thought there was two different ways I could do this. I just was making sure we didn't switch because I haven't been paying a whole lot of attention.
No, we
Yeah.
only have just one answer.
Only one answer.
We
Okay.
only have one solution because we turned that to linear equation.
Oh, that was wrong. Okay, I actually. Okay, sorry.
I
Gotta
don't
fix that.
know. Okay, so let's see. What's your first step? Okay,
I'll do that.
first step. Make sure we understand first step. First step is combine them, which give us 3 and x minus 1. Yeah, are we good here? Okay, yeah, and so therefore we know 3 x minus 1 should equals to 12, right? Yeah, are we good on the second step?
We're good.
Yeah, Elsa, we good? Next step, okay. So therefore we divide by 3 on both sides. So then x minus 1 is equal to 4, right? So then add 1 on both sides, then x is 5. And we can always check. 5 minus 1 will be 4. 4 times 3 is 12. So this is therefore that's the answer. Good? Yeah. Okay, let's try. Okay, let's see what you got.
Hmm.
Good job,
Yeah, I
Maury.
forgot a step.
Good job, Elsa. Yeah, good job, Jet.
I think I forgot a step.
Okay, well, what you got?
It was that.
No.
Yeah, that's not right though.
Okay, so the first thing again is 5 times x plus 2, right?
Mm-hmm.
And that equals to log 25. And we got 5x plus 2 equal 25. Divide by 5 on both sides. Then x plus 2 is 5. So minus 2, x equal 3. Good?
Okay. Yeah.
Okay. All right. Now we're going to looking at a little bit different is what we're going to do when we're dealing with negative. For example, we got log 4x plus 3 minus log 4x minus 3. And that equals to log and 2. Good. Now, we know that the difference when we have that is basically is going to be this. Is going to be log if we combine them. The reason we combine them is trying to get rid of log, okay? So combine them on this side, that'll be 4x plus 3. And this side will be 4x minus 3. And this side, of course, is log 2. So therefore, 4x plus 3 over 4x minus 3, that equal to 2. Now, what we got here is called a rational equation. It's a quotient of two polynomial equations. So therefore, we times 4x minus 3 on both sides. And that cancels. So we got 4x plus 3 equals to this get distributed. So it's 8x minus 6. Yeah, I like to dealing with positive. So I write this as this 4x plus 3. So therefore, that's a linear equation. So minus 4x on both sides. We got 4x minus 6 equal to 3. Then we add 6 on both sides. We got 4x equal to 9. We divide by 4. Then x is 9 over 4. Good. Yeah. Usher? Chad? Okay.
Wait. Oh,
Morgan?
Yes, I'm just, maybe I missed something, but I'm just curious how 4x plus 3 over 4x minus 3 equals to 2.
4x minus 3. Oh, this side. Look at here. Right?
Oh, whoops.
Same thing.
Okay, I didn't see that. I'm sorry.
That should equal to 2. Good.
Okay, yes, sorry.
Yeah, Usher, we good?
yeah, I'm sorry. I'm reading it currently. So 4x. I mean, I guess I don't really. I'm gonna be honest.
I've got a question.
Yes.
How did 4x minus 6 equals 3 become 4x over 4 equals 9/4?
4x over 4.
Oh, wait, never mind. That was a stupid question. Sorry, that's it now.
That's all right. That's all right. So what we did here, we actually changed this into a rational equation, and then we changed the rational equation into a linear equation. Good. That's basically what we're doing is no matter what kind of equation we have, we're going to change that into either a linear equation or quadratic equation that help us to solving it. Okay. I'll give you one. Let's see. We got log x plus 7 minus log x minus 2, and that equal to log 3. And see what you got.
Not entirely sure how to solve this. I'm gonna be honest. I don't remember all this stuff.
Well, the only step we add to it is change this one to this. Good.
Oh, so we're just dividing them?
Well, the difference is a division, right? Remember
Mhm.
how to do the law?
That makes a lot more sense.
And then therefore, what we got here is x plus 7 over x minus 2 equals 3, right?
Hmm.
That is,
Wait, how does that work?
well, this side has to equal to that, right?
Oh, well, yeah, sorry. No,
Yeah,
that makes
well, that's
sense.
all right. So now we have a rational equation. Then from the rational equation, we change that to a linear equation. Okay?
Okay,
Mhm.
I'm following.
Oh, yep. Okay. Good job, Jet.
Okay, I'm not understanding what to do after this.
Well, which is times x minus 2 on both sides. So we turn that into a linear equation. Good. We times x minus 2 on both sides. The reason we do that is then this got canceled. So we got x plus 7 equals to 3x minus 2. So that's a linear equation, right? And we solve it that way.
Mm-hmm.
Make sense?
Yeah.
Okay.
Yeah, I remember this step. I just forgot it.
Mm-hmm.
Oh, okay. I think I've got it.
Okay. No.
Okay.
And how do you got that?
Well, my guess was first step is to multiply 3 times x minus 2.
If x
So that
got
would be,
if x got multiplied, they have to go both. That's distribution.
yeah. So that would be 3x minus 2
No, minus 6.
or minus 6.
Yep. Okay.
And then uh, subtract the numbers. So that would be minus 1. Wait, I'm confused now. I don't know.
Well, this one rewrite as this, right? It's linear equation. Yeah, are we good here?
Mhm.
So minus x on both sides, what we have? We got 2x minus 6 equal to 7. Then we have moved 6 over, plus 6 on both sides. Then 2x is 13. Then divide by 2 on both sides. So x is 13 over 2.
Okay, that makes sense.
Okay.
I think I've got it.
Okay. Morgan and Elsa?
That makes sense. Thank you.
Okay. Morgan?
Yeah. I think I might have it. Yeah.
All right, let's try another one, okay? Um, okay, let's see.
Yeah, I still don't understand.
Yeah, I'm not quite sure where kind of um mm, what's your what block do you
I
from
just
here? What you got?
so I'm supposed to divide them or divide them from each other, right? So it's
We know this is
uh x minus 3 over x minus 1,
yeah. Now
and then
equals
I have to equals
3.
3. So
So therefore, x
and
minus 3 over x plus 1 is equal to 3, right?
yep, yep.
Then what we do next?
Uh multiply x minus no, I don't remember. I don't remember.
Well, how do we change that to a linear equation?
I don't remember. So I'm just gonna be
Well,
honest.
it was this x plus 1 times that.
Okay, that's what I thought.
Huh?
I thought so. It just you added it to both sides.
Well, you have to do
Doc,
it on both sides, right?
Yeah,
What you got once you got this out?
hey,
those
Dr. Pink,
cancel out.
Yep.
why is the positive on top? Why is the negative on top of positive?
What do you mean?
Why is the x minus 3 on top of the x plus 1?
Well, this is this minus that. Anything in front, the negative sign.
Oh,
So this is this x over y equals to log x minus log y, right?
okay, cool. Thank you.
Okay. Yeah. Morgan and Elsa, are you guys
Mhm.
on this step?
I'm good until the very end of the equation. I'm good at that step. Yes.
Okay, so what we got here? How about you, Morgan?
I'm with Elsa. I'm good to like right at the end.
Oh, let's say x minus 3 is equal to what? This, right? Are we good?
Mhm.
Which is 3x plus 3, right?
Yes.
Okay. Then I'm going to flip this one. Good.
I think I have an answer. I just
Yeah.
not a-
Then
not 100%.
minus x on both sides. What we got? Do we-
That's where I'm confused because it's 3x on one of them. So
Right.
like I don't know what to do with that. Do I just
So
leave?
if you subtract the x's, right,
What do you mean?
that'd be 3 plus 3 is
Yeah.
equal to negative 3.
Can you solve this equation?
No, that's what I'm struggling to figure out. I'm subtracting both x's, but like what does that leave with the because it's 3x. So does that mean there's still 2x there, or does that mean that the 3 stays there, or does it just disappear
It means
completely?
the 3 stays there.
If we minus x on both sides, what is 3x minus x?
3.
2x or
Yeah, 2x. Okay.
yeah.
So we got 2x plus 3 equal to negative 3, right?
Okay.
Then what do we go from here?
Well, you subtract the 3.
Right, okay, what do we have?
So 2x equals negative 6,
Right,
and then divide it by 2, which would be x equals negative 3.
right,
Okay, that makes sense.
good.
Thank you.
Yeah, how about you, Morgan?
I think I have it. Yes. Thank you.
Okay, so let's try. Let's try one. Okay, x plus 3 minus x minus 2 equals log, let's do 5. That's what we have. Good.
Okay.
Good job, Jed. Uh, I thought made a mistake somewhere. Yeah, just
Okay.
check your steps.
I probably need to get this wrong, but I think I got it.
Okay. That's not it.
Yeah, that's not it. Okay.
It made
Make sure I got it.
some mistake along the
I probably haven't memorized all the steps then.
well, actually, if you understand the purpose of doing steps, you don't have to memorize it. Because once it makes sense, then I mean you'll
Yeah,
stick
I
with it.
think what I was doing was I got down to uh x plus 3 is equal to 5x minus -10.
So x
And
plus 3 is equal
I
to,
couldn't remember the step after that was to subtract the x's, right?
right. You got this step, right?
Yes, I already completed that. It was I got to x plus 3 is equal to 5x minus 10.
Yep.
So
Very
that's
good.
the step after that I thought was to subtract the x's.
Yeah,
Or am I wrong?
yeah.
So then that would be 3 is equal to 5 minus 10, right? because after removing the x, that basically is, or 5 minus 10 is equal to 3.
5 minus 10 equals plus 3. Well, if you're trying to get rid of x on this side, what happened to on the left side?
It's also removed.
Yeah, it has to. Anything has this is equation. Remember, anything you did on the left, you have to do the same on the right. That's the
Right. You're completely right.
Okay.
Yep.
Then what you got?
And that would be 5 minus 10. So that would be 5,
How many-
presumably.
How many x? We take a 1x on both sides. How many x left?
None.
Huh? 5x minus x is?
5.
Are you sure?
That's what I've been led to believe, I think.
5x minus x is 4x.
Right.
That's where I went wrong.
Oh, I thought x was removed entirely.
No.
What?
Think about 5 bags of apples. Take out 1 bag of apples. How many apples you still have?
Yeah, that makes sense.
Have 4 bags, right?
Yeah.
Good.
Yep. So
Okay.
then what do I do after that? So if I have 4x minus 10 is equal to 3.
4x minus 10 equals 3. That's a linear equation. How do we solve that?
Yeah. You would add 10 to 3. That would be 13. So 4x is equal to 13.
Right.
And then divide that by 4.
Right. And what's our x then?
That would be 13 over 4.
You're right.
Or x is equal to 13 over 4.
Very good. And that's it. Okay.
All right. Thank you.
Yeah. We good, Elsa?
Yep, I made a
I
mistake.
Okay.
think I understand now.
Okay, very good. Morgan?
Yes, I have it.
Okay. All right. That's good. I'll see you guys next week. Okay.
See you
All
next
right.
week.
Thank you very much.
Thank you.
See ya. Thank you very much.